Hi students, welcome to S&M Coaching Center. We have started the board examination revision series, and as part of it, we have started with real number. This can be useful for both the 10th CBSE as well as the state 10th students. Yes, let us continue with today's sums. What is the first question? They said the HCF of two numbers can be written as like this. So he is asking us to find the value of m. So let us write what are the two numbers. Two numbers are 408 and B is 1032. And then what is the HCF? HCF is the given expression, which is 1032m minus 408 multiplied with 5. Now what is the question? Question is, he is asking us to find the value of m. Okay. So, since they did not give us the value of LCM, what is that? We have to use the prime factorization. Let us find the prime factorization of 408. 2 2's 4, 2 zeros, 2 4's 8. 2 1's, 2 0, 2 2's. 2 5's 10, 2 1's 2. 3 17's 51. So, prime factorization of 408 is how many 2's? There are 3 2's. So, 2 cube into 3 multiplied with 17. Repeat the process for 1032. 1032. What is the prime factorization? 2 5's 10, 2 6 32. 2 2's 4, 5 minus 4 is 1, 1 and 1, 11, 2 5's 10, 11 minus 10, 1, 1 and 6, 16, 2 8's 16, 2 1's, 2 2's 4, 5 minus 4 is 1, 18, 2 9's. Now this ends with a odd number. Count the digits, add the digits, 9 plus 1, 10, 10 plus 2, 12. 12 is divisible with 3, 3 4's 12, 3 3's. Now, as we all know, 43 is a prime number. So, the factors of 1032, 1032, what are the factors? 2 cube and a 3 and a 43. Now, he is saying from the HCF, we have to find the value of m. So, let us first find the value of HCF of the given two numbers using the concept. What is HCF? HCF is product of all the common factors with the least powers. Which are the common factors? I have 2 and 3 as the common factors. Out of 2 and for 2, which is the common least power, both have the same powers. So, I will consider it as a least only. 2 cube, multiply it with, again 3 have the same power. So, take it as this as it is. So, 2 cube is 2 2's 4, 4 2's 8, 8 3's is 24. So, we got to know the HCF of the given number is 24. But what is that he is saying? HCF can be written like this also. So, equate the value of HCF that we got with the expression. So, what does it mean? 1032m minus 408 multiplied with 5 is equals to 24. So, what is that we have done? We knew, because we have done the prime factorization, we know the HCF of the given numbers is 21, but they have expressed the HCF differently. So, equate both values, we will get the value of m. So, 1032m, do the multiplication here, 5 8's 40, 5 4's 20 is equals to 24. Next, transpose the number 2040 to the other side. When a negative number is transposed to the other side, it becomes positive. So, this becomes 24 plus 2040. So, 1032m is equals to, add both the numbers, it becomes 64. Now, keep m here, transpose the number to the other side. Since m and the number are multiplying on transposition, the number will divide. So, it will be m is equals to 2064 divided with 1032 as the number. It is very obvious. you can cancel it directly with 2. So the value of m is 2. The value of m is 2. If you cannot see the below steps, what I will do, I'll just rewrite the last 3 steps just in case you cannot see it from here. I will write it here on the right hand side. 1032m is same as 2064. So m is equals to 2064 divided with 1032. So that as the number is very clear, m you can cancel it. M value is 2. If you can see the board below, yes you may. If not, you may copy the last 3 steps. Yes, let us move to the next question. See children, all the sums that I have been doing in the different videos under the revision series, these are all either the important questions or these are the PYQs. So please do not ignore. You may expect similar sums but with a different number obviously. So please do not ignore. These are not present in your NCERT. So we are giving you the PYQs and the different kinds of the sums that you may expect in the board. So all of them are very, very important. These are the PYQs. You can expect similar sums for your board exam. So the next one is very important. See, all the sums that I am teaching here are very important, but this is theoretical sum. So let us concentrate on this second sum. Show that 9 power n cannot end with a digit 0 for any value of 9. So first, let us understand what he is saying, what the question is all about. He is saying there is a number which is written as 9 power n. He is saying this cannot end with a 0 in the units place. For example, if I take n to be 1, what is the value of n power n? N power n, 9 power n would be 9 power 1, which will be 9. It has only single digit. Is it ending with 0? No. Let me take n to be 2. So n square will be 9 9s 81. And is the 81 ending with is the unit digit? Is it 0? No. Right now I have done only for n values of 1 and 2. What is he saying? For any value of n, which means even if you take n to be 100, 200, 3000 or anything, he is saying it should not end, the value should not end with 0. So obviously we cannot take values of n from 1 to infinity and prove and show that. See, this is not the case. So how do we show that? We have to generalize and see. And now let us see. Any number which ends with 0, he is saying it cannot end with 0. So first let us see what will be a number that ends with 0 looks like. Let me take a number 160. This is a number ending with 0. Now, if I do the prime factorization, let me see how the prime factorization for any number ending with 0 looks like. What is the prime factorization? 2 80s, 2 40s, 2 20s, 2 10s, 2 5s. So 2, 1, 2, 3, 4, 5, 2 power 5 into 5. Let me take some other number. Let me take 90. 2 45s, 5 9s, 3 squares. So for some other number, for 90, what is the prime factorization? It is 3 square into 2 and 5. So now look for common factors in both the numbers. What is the common similarity of both the numbers? Both are ending with 0. So there should be a similarity in the factors also. What is the similarity? The similarity is the prime factorization has at least a single 2 and a single 5. So what is the any number which ends with 0? What is the common thing they have in their prime factorization? They contain at least one 2 and at least one 5. So the prime factorization of any number ending with 0 should contain a 2 and a 5. That much is very clear for now. Now let us jump to the concept. The concept is 9 power n. Why it cannot end with 0? How to solve this? Given, what is the given number? Given number is 9 power n. Write the factors of 9 power n. 9 power n can be written as 9 can be written as 3 multiplied with 3. So what are the factors of 9? The factors of 9 is only if you have only 3. Now, when can a number end with 0? A number can end with 0 if its prime factorization has at least one single 2 and a 5. But unfortunately, 9 doesn't have a 2 or 5. It should have both or Allah. It's not the case of or, it has to be the case of and. 9 doesn't have a 2 and 5 in its prime factorization. So, how do we write? So, obviously, we know 9 power n cannot end with 0. But how do we write this? So, we write this. We know that a number ending with 0 has 2 and 5 in its prime factorization. Prime factorization. However, 9 power n doesn't have 2 and 5 as its factors. Hence, 9 power n cannot end with a 0 for any value of n. This is how you have to write the theoretical questions. Take down, children. Now, see, this question concept will remain the same, but numbers they will change. Sometimes they may give 9 power n, sometimes they may give 6 power n, sometimes they may give 4 power n. Concept remains the same. Whichever is the number that they are giving, find the factors. Obviously, you will see that you will not find both 2 and 5 as its prime factor. This one will remain the same, except here instead of 9 power n, whatever number they have given, you have to replace it with that number, not with 9 power n. This remains the same. Everything else you have to change according to the given question. Got it? Copy, children.